Okay, in this question we're going to use the Simplex method to go ahead and complete the solution to the question we did in the previous topic, and that was setting up the initial Simplex tableau for this applied problem. You remember that we had the manufacturer of bicycles who builds three different kinds of bikes, and we applied our methods of translating all these words by first of all choosing X1 as the racing bikes, number of racing bikes, X2 as the number of touring bikes, and X3 is the number of mountain bikes. Now the bicycles are made of two different kinds of material, aluminum and steel, and the company has 91,800 units of steel and 42,000 units of aluminum. Now we also noticed that we had racing, touring and mountain bikes will need 17, 27 and 34 units of steel and 12, 21 and 15 units of aluminum. Now how many of each type of bike should be made? So here's our question. How many of each type of bicycle should be made in order to maximize the profit? If the company makes, alright, so we're maximizing the profit, if the company makes $8 per racing bike, $12 per touring bike, and $22 per mountain bike. So that's the first part of the question. Alright. Now the second part of the question is this: what is the maximum possible profit? Alright, now you'll recall that when we did this question, we in topic 5.1, and you can go back and review the video, you'll notice that we ended up with this initial Simplex tableau. Alright, now you'll notice, and of course what we do usually is we have a line across here to separate the bottom row, and we have a line down here. And this is our initial Simplex tableau. Now we go ahead and we now want to determine where is the most negative indicator. Well, that's this negative 22. Okay, so step one, and I'm going to try and jam things up a little bit here because we don't have much room. Step one, alright, identify the most negative indicator. Alright, so of course this is 22. Right, and then step two, and you'll need a calculator for this, so you might want to pause it and make sure you've got a calculator. So step two is we want to now identify the pivot element. Alright, now the pivot element comes from the ratios. If I look at this, this is the column I'm looking at. Alright, and what we have to do is look at the ratio of 91,800 divide by 34, and we've got to look at 4,200 divide by 15. So using your calculator, alright, this is what we get. So we put in our 91,800 and we divide it by the 34 and we get 2,700. Alright, now we get our 4,200 and we divide that by 15 and we get 280. So clearly this one here is the smallest. Alright, now Alright, now given that we have that one's the smallest, that means that we go along here and we can identify our pivot. Alright, this one here is the, so let's just make sure that's correct. So we have 42,000. I think I need that an extra zero there, don't I? So be careful of that. So it's actually 2,800. Alright, so 42,000 divided by 15 is 2,800, so this is not the smallest, this is the largest. So this one here is the smallest. Okay, so be careful of your ratio. Alright, with your arithmetic. So that means that we now have this is our pivot. Alright, so we have our pivot element. Now what we have to do is we need to get zeros below there. So step 3. Alright, we're going to use row operations. Right, to obtain zeros above or below, in this case it will just be below, above or below, and below I should say, below the pivot. Alright, so in this case it's just below them. Alright, so let's have a look at that. Right, so what are the row operations we're going to need to use? Now this is where the numbers can become difficult with our Simplex method, because we're dealing with real situations, and real situations are sometimes got difficult numbers, and in actual fact more often than not. So the easiest way to do this is to start looking at the a common multiple of those two, and of course 34 times 15 would be a common multiple. So what we might want to do here is multiply row 1 by negative 15. Okay, and we want to add, alright, we're going to need to multiply 34 by row 2, right, to produce this new row 2. Okay, that'll be the first thing to do. And we need to get rid of this negative 22, so we're going to need to try and look at something between those two. 22 and 34 could have a common multiple, and 17 goes into 34, so I think 11 and 17 will probably work. You can play around with this to make sure. Alright, but we could do 11, so let's do this. 11 R1, okay, because 11 R1, so if you multiply 34 by 11, let's just check our arithmetic, we'd end up with 374. We would want to add 17 times row 3. We already have a negative there, so let's look at 17 times 22 is also 374, so that's going to work. So 374 is going to be the least common multiple between 34 and negative 22, and that will produce a new row 3. Right, so let's get our new tableau here. So we'll have an x1, we'll have an x2, we'll have an x3, we have an s1, an s2, and a z. And of course our first row stays the same, 17, 27, 34, 1, 0, 0, and 91,800. Alright, now comes the tricky part, and we want to look at this. So we're going to have a negative 15 by 17 plus a 34 times 12. Okay, so do your arithmetic on that. So notice that we're multiplying this row 1 here by negative 15 and this row 2 by 34, and we're adding them together to get a new row 2. So check your arithmetic and you should get 153. Right, same thing here. 21 times negative 15 and add 34 times 27, and you'll end up with 309. So check my arithmetic, make sure you got your calculator. And next, of course, we have negative 15 times 34, and we're adding 34 times 15. Okay, so that will give us 0, which is what we were looking for. Okay, so just be careful and be careful of checking the arithmetic. So negative 15 times 17, add 34 times 12. That will give you the 153. Your negative 15 times 27, add 34 times 21, should give you 309. And now, of course, negative 15 times 34 plus 34 times 15 added together will give me 0. And, of course, now we have 0. Alright, plus, so we have negative 15 here, plus 0, so I've got a negative 15 there. Okay, we have here row 2, we're multiplying by 34, we're adding 0 and 34, so that'll give me a 34. These ones are easy, fortunately. And finally we have 0 plus 0 is still 0. Now here's the tricky one. We have 42,000, and we're going to multiply that 42,000 by 34. We're going to multiply 91,800 by negative 15. Okay, so we've got it here, times this one by negative 15, and multiply this one by 34, and then add them together. And and then when you add them together, so you're going to get a negative 1 and a positive 1, and when you add those two together, if my arithmetic is right, I get 51,000. Okay, right, we put our line underneath. Okay, so that's our first one only. And now, of course, we have to do our second one, which, of course, is 11R1. So we're multiplying 17 by 11, and then we're adding 17 times negative 8. Alright, so make sure you follow that. So 17 is times the 11. 11 times 17 there. And then R3 is 17 times negative 8. And what we get there is going to be 51. Right, then notice that we have 11 times 27 plus 17 times negative 12. Add them together and you'll end up with 93. Okay, so put your calculator to good use. Now notice here that we multiplied this one by 11 and this one by 17, and we would have got 374 minus 374, so that should give us a 0. Okay, now notice that this one's being multiplied by 11, so we're adding 0 and 11, so we get 11. This one we get 0 plus 0 is still 0. And now we have 1, which is being multiplied, that's in the third row, by 17, plus 0 is 17. Okay, and now, this is an interesting one, we're multiplying this 91,800, alright, by 11 and adding to 0. So just 91,000 times 11, and that will give us 1,009,800. Alright, so remember this one here is coming from 11 times 91,800. Alright, so here is our matrix, like so. Right, so step 4, right, check for negative indicators. Alright, so we're looking for a negative indicator, and of course there is none. So it would appear that we're finished, okay, because the last row is all non-negative. Notice we have some zeros, but it's non-negative. Okay. All right. So what we've got to do is look for step 5. All right. We need to look underneath where these zeros are. All right. The columns with zeros in the last row. All right, and we should, all right, identifies basically the variables that we are going to keep. Now you'll notice that we have a 0, so we're talking about this x3 is what we're going to keep, and we're looking at S2. Okay, alright, so that is x3 and S2. Right, so what we need then is, okay, we need to, step 6, we need ones, 1 in the 34 position, all right, under x3, and we need a 1 in the 34 there too. All right, in the 34 position, under S2. So to do that, we're going to need to do 1 on 34 times row 1 to produce a new row 1, and we're going to do a 1 on 34 by row 2 to produce a new row 2. So again, get your calculator. So step 7, we produce what's called the final simplex tableau. Alright, so here we go. X1, X2, X3, S1, S2, and Z. Alright, so we're going to divide everything through, right, by 34. So 17 divided by 34 will be a half in that position. We're going to have 27 divided by 34 on the next one. Okay, we're going to have a 1 here, which is what we're looking for. We're going to have a 1 on 34 here. Okay, this is a 0, so this will stay at 0. And this will stay at 0. And now, of course, we're going to need 91 91,800 divided by 34. So 91,000, so we'll need a 91,800 divided by 34. And if my arithmetic is correct, that should come out to be 2,700, which is exactly what we had up here. Notice that. Okay, that's that one. Now let's do the next one's going to be 153, and we're going to divide that by 4. Okay, and then we're going to have so 153 divide by 34, and we may be able to break that down, I'm not sure, but anyway, then we have 309 divide by 34. We're going to have a 0 divided by 34, so that's 0. A negative 15 divided by 34. Okay. And we're going to have here 34 divided by 34 is a 1, which is what we're looking for. A 0 divided by 34 is that. And then we have a 51,000 divided by, so we get 51,000 divided by 34. And if my arithmetic is correct, that should come up to 1,500. Alright, so now we put our line. Like so. And now we're doing, okay, so of course we need now, remember, so let me circle these ones. We need a 1 here, we need a 1 here, and of course we've got 17z here. Okay, so I'm going to need to divide this by 17. So that's our next one. 1 on 17 times R3 produces our new R3. So it's going to be 51 divided by 17, which is 3. We're going to have a 93 divided by 17. We're going to have 0 divided by 17 is still 0. We have 11 divided by 17. 0 divided by 17 again. A 1 here, which is what we're looking for. And now we need 1,009,800 divided by, so we need, so that's this one. So we need 1,009,800 divided by 17, and that's going in here. And when you do that, you get 59,400. Okay, so that's our final tableau. Now we're getting a bit jammed up here, so let's answer the questions we need to answer. Now notice we have here how many bikes of which kind do we need to produce to maximize the profit. So at the moment we have a maximum profit, and we're going to need, right, 2,700 of X3. Okay, so what our tableau is telling us, if you come across here, is that X1 is 0, X2 is 0, X3 is 2,700. S1, right, is 0. Okay, and we're not really worried about these anyway, and S2 is 1,500. That's a surplus variable. So the one we're interested in is this one. So this is telling we should make no racing bikes, okay, no touring bikes. So in other words, this company, to maximize the profit, so no touring bikes, and the company should make 2,700 mountain bikes. And the maximum profit, okay, all right, will be right here. All right, $59,400 by doing that. Okay. All right, now you can check to see a couple of interesting things here. All right, notice that here's our profit. All right, shows up here. We need to make sure we got ones here and here because these are the two variables that have significance. Okay. Now an interesting exercise here also is to see, right, if we put the 2,700 in for one of these constraints, for example, remember this one here is looking at the steel, so it would be 0 of these, 0 of these, and 34 times 2,700. Interestingly enough, we get this number here. Alright, so notice that comes from here, of course. 91,800 divided by 34 is 2,700, so 2,700 times 34 would give this. So in actual fact, all the steel is going to be used up, making this 2,700 mountain bikes. Okay, notice that if I put it into this constraint here, okay, you'll find that 0 plus 12 times 0 plus 21 times 0 plus 15 times 27, all right, actually produces 40,500. So notice, let me put a little note up here. So notice that 15 times 2,700 gives me 40,500, and this is the units of aluminum, all right, that that would be used in producing those mountain bikes. Notice that it's short of the 42,000 by 1,500. Notice the 1,500 right here was our slack variable. Okay, and that's the amount of unused aluminum that we have in making this 2,700 mountain bikes. Alright, so that's how we do the applied problem. So make sure that you view this video here first to understand how we got the initial Simplex tableau, and then you work your way through it as a normal Simplex method procedure.